Okay, I think we can probably get started. It's 20 past. So good morning, everyone. My name is Nick Murison, and I'm going to be spending some time with you this morning talking about software security and how to build security into your development practices. So just a bit of background. I started out in the security space about 16 years ago doing research and development at HP Trusted Systems Lab. Got hired by a security consultancy in the US, started doing penetration testing, secure code reviews, ended up sort of working more on sort of strategic application security stuff after a while. And now I'm a practice lead at Miles, which is a consultancy here in Oslo. As you can see, I like cycling as well. So what I'm going to be talking to you about today is a bit of a software security introduction, a little bit of history behind it, and also then how to actually build security into your software development lifecycle and associated things. And also I thought I'd share some resources with you around some of these things that you can go and look at afterwards. So first of all, what is software security? Well, it's all about building security into software. It's not about building security software like antivirus and firewalls and so on. It's about actually making software secure from attack, from hackers and so on. It's not quite the same as infrastructure security, but it's quite related. Infrastructure security is all about networks, servers, and so on, while mostly what we're going to talk about is kind of, shall we say, the application layer. Which is why a lot of times people call this application security. And I'll talk a bit about why I prefer software security as a term over application security as well. So why, well, what is software security? Well, it's more than just, for example, cryptography. Crypto is a big part of software security in the sense that it's a critical building block. It gives us things like encryption, so we can support confidentiality. It gives us hashing and digest and stuff like that. So it supports integrity of data, checking integrity of data and so on. But it's a building block. It's not a silver bullet or the solution to all our problems. It's more than just authentication. Authentication is one of several security controls that we want to have in place as part of a system or software that we want to design and implement in as part of it. Other examples are things like authorization, input validation, session management, kinds of things. They're all sort of part of the set of controls we need to implement. More than just web app. And this is maybe where the term application security is used a lot for what we, when we talk about web apps. Software security is more than just web apps. It's mobile apps, it's operating systems, it's Internet of Things devices, it's cars, medical devices, washing machines. My tumble dryer has Wi-Fi. I still don't know why, but all of these things, they run on software. It's more than just cross-site scripting. Which is probably something that you've all heard of. There's lots of different types of vulnerabilities, lots of different classifications of vulnerabilities, and they sort of depend on what kind of software we're targeting. So, if it's a web app, cross-site scripting makes sense. If it's an embedded device, things like buffer overflows might be more relevant to test for and to protect against. And it's more than just penetration testing. So I've got a rant later on today as a lightning talk about penetration testing. It's not really a rant, but that's one activity that we can do as part of this whole process. Pen testing is great to find issues in software, but it's not the only thing that we can do. And in particular, it's very good at finding issues. It doesn't fix issues for us. There's other activities that we can do to enable that. And I'll talk a bit about those a little later on in the talk. So a very brief history lesson, which is entirely my view on it and glosses over a large part of stuff, but for the purpose of the talk, I wanted to sort of just have a thread, a history thread to talk you through. So a lot of stuff has happened, and this is some of it basically. So first of all, let's break it down into kind of a few different decades. So pre-1990s, computers existed, systems existed, they talked to one another, but there weren't that many of them, and the ways that they communicated were fairly dedicated point-to-point kind of setups. So big academic institutions and research institutions had big computer systems, and they would talk to one another. But for the average person, there wasn't necessarily, the internet and the web as we know it today. War dialing, phreaking, those kinds of things did exist then. So hacking was very much a thing back then. Security vulnerabilities were a thing back then. The Morris worm predates 1990 by quite a bit. So security was still a concern, but you could argue that security was perhaps easier before then, although I'm sure there are some people who would disagree with that. Then around about the mid-90s, well, early 90s, a lot more of us got on the internet. I'm sure quite a few of you probably remember dialing up and getting onto IRC or BBSs and so on, early 1990s. And then around about the mid-90s, things started to change a bit. So Windows 95 came out, a lot more households got dial-up, and essentially there was kind of a democratization of the internet. So a lot more people on it, a lot more websites came up, and there was just more things to do. And because there were more things to do, more systems live, it meant that hackers had a much bigger playground to mess around with. And this is kind of when infrastructure security became a big thing. So firewalls and network segmentation became a crucial part of any kind of company strategy for security. So talking about hackers, what's the whole point of hacking? Well, hacking is pretty much born out of a curiosity and a sense of wanting to make systems do something that they weren't intended for. There's sort of a sense of accomplishment and mastery, craftsmanship that comes from breaking these systems. A fairly classic example is buffer overflows and stack overflows. So there's an online magazine, or a magazine called Frack. And back in 1996, this guy called Aleph1, who also has a real name, he wrote an article that was pretty seminal at the time, really, called Smashing the Stack for Fun and Profit. And it talked through essentially how software sometimes wouldn't check how much input it was getting from a user or from another system or from somewhere else, and it would try and stuff it into a memory location that was too small, and how then you could use this to overwrite memory, take control of execution, and so on. And to this day, viruses and worms largely still rely on something along these lines to exploit systems. So with hacking on the rise, companies do start defending themselves. So what do they do? Well, the classic go-to is a firewall and any other kind of network segmentation. So a firewall, the most basic explanation was, let's separate our soft, squishy internal network that has no security from the big bad internet. And so let's stick a firewall in between. A lot of companies got a bit more advanced than that. They would have different networks for different things, and so they'd have a different firewall in between the different networks and so on. This worked great unless you actually needed to expose some sort of service to the internet. For example, a website or a web app. So for web apps to work, you've got to put out, or you've got to expose a couple of ports, usually TCP port 80 and 443. They have to be exposed to the outside world. So from an attacker's point of view, okay, there's a big bad firewall. I can't telnet to your servers, but I can talk to your web app. And what if the web app wasn't particularly well written or wasn't very secure? What if it was vulnerable to issues? And that's where a lot of hackers started having fun with web apps. So firewalls didn't fix all the problems for us. So we needed to start looking at fixing the actual software. And so there were a few people around about the early 2000s that came out with some good material on this. So Mike Howard from Microsoft wrote Writing Secure Code. Gary McGraw from Digital wrote Software Security, Building Security In. And John Yeager from Secure Software, he wrote this Building Secure Software book. And these all have a lot of really great information in them. A lot of it's still relevant today, in fact. And so, for example, Mike Howard's book, Writing Secure Code, sort of talks a bit about how Microsoft, after Bill Gates sent out a memo saying we need to get better at security, they developed the secure development lifecycle. And so a lot of companies are trying to copy what Microsoft said that they did. And some of it worked, some of it didn't work for other companies. So back then, most development was still kind of in a waterfall approach. So one of the main challenges with getting security into software was how the software was built. So if you've got a waterfall approach, going backwards, so to speak, from one stage to another isn't the easiest thing to do. So pressures like time, budget, basically meant that security, it was seen as a cost, an added time to development. So a lot of times what you'd end up with as a secure development lifecycle would look something a bit like this. So you wouldn't have time during requirements. Architecture was, you didn't think about security then. While you're writing the code, you would probably press for time, so you didn't do it then. And then when it came to testing, well, we'll do a pen test when we're in production. And that, as a security consultant, was my experience in a lot of cases where companies would hire us in to do a pen test, and they hadn't done anything security-wise up until this point. So that was a painful experience for them, because it meant that I would find a bunch of problems, and then they'd have to go back and fix it. But the one-way structure, so to speak, of the development lifecycle meant that it was kind of tricky to do. Some companies got a little bit wise to this and thought, okay, well, what if we shift things left? And that was the 3 books that I talked about, all talked about this concept as well, is, move to the left. So get things in earlier. So for example, we could do security requirements as part of the requirements phase. We can do some sort of risk analysis of the architecture. We can do a code review, maybe using a big box static analysis tool. And then while we're doing our functional testing, let's try and do the pen test then before we go into production. And then we might have to do repeated pen tests in production, like once annually or something like that, because we have requirements against some regulations or industry standards that we have to follow. Now, the challenge here is that these activities were designed in such a way that they took quite a lot of time. So, requirements analysis would take a couple of weeks for some reason. Architecture risk analysis, which is fairly heavyweight, would take at least 2 weeks. Code reviews, if you're using a big box kind of static analysis tool, Fortify, Coverity, these types of tools, they are really good at finding bugs. And they are very good at finding quality bugs, in the sense that, or security, good quality bugs, in the sense that, they will go deep, they'll be detailed, and they'll have a lot of coverage of the code, and they'll find some really interesting stuff. But the problem is that they take a while to run. And then, especially in the early days, they were a little bit overly trigger happy and would tell you lots of things that were wrong that weren't actually wrong. So they produced a lot of false positives. So, well, maybe took about 8 hours to run. Then you'd spend the rest of the week figuring out, okay, which of the things are actually really a problem for us. And then in the testing phase, you maybe give some pen testers a 5-day window to test the app, and pray that they didn't find anything too bad, because you were in testing phase, you didn't want to have to go backwards again. Now, all these things took time, and so that was a challenge. Project managers didn't like us because we'd introduced this time lag. Developers didn't like us because we'd introduce problems late on. But in some organizations, this was kind of seen as, well, this is how we have to do it. And then things got more interesting when a lot of organizations decided to adopt kind of more of an agile mindset. Some of them adopted agile processes and agile methods, and various misinterpretations perhaps of agile. I have on purpose spelt it with a capital A just to annoy people. This is what I got from a lot of companies when I was working with them, was they would say, oh, we're agile now. And then you start asking them, okay, well, what does that mean? And really all I meant was that they were doing Scrum sprints, 2-week sprints, for example. Now that became a problem for the security team, because now they were faced with a challenge. How do they do all the security things that they want to do in a development life cycle, so to speak, that looks entirely different from waterfall? So some security teams would do the thing where they would actively fight against Agile and say it's not worth it. It's all just going to make us horribly insecure, so we shouldn't do it. And so they fight actively against it. Others would say, okay, well, we'll go along with Agile. We'll just do our same things, but we'll try and do them faster. So, trying to do pen test that takes 5 days, we'll try and do it in 4 hours. You're not going to get the same results. You're going too fast to get the same level of depth and technical detail, so you're going to miss out on things. So there was a bit of a conflict there, and it was brewing, and essentially, the security guys were saying, we can't work this fast, and the developers are saying, you're slowing us down with all the security stuff, and we had conflict. So there were some efforts to see if we could kind of bridge this gap, and I wanted to bring up these three because they're still relevant today, and they're still very much active today. So I thought they would be good resources for you to look at. So OWASP, I'm pretty sure most of you have heard of OWASP, the Open Web Application Security Project. If you saw Nancy's talk yesterday, then she spoke about it a bunch. And essentially, it's a voluntary effort. It was originally created to sort of collect relevant, actionable knowledge to help security people understand development and to help development people understand security. Originally, it was just for web. Now they've got resources on mobile development. They've got resources on containerization and so on. And it's pretty well respected to the point where, some of the industry standards like PCI DSS essentially says, do the things that OWASP say to do to a certain extent. That's horribly simplified, but you get the idea. OpenSAM is a maturity model originally funded by Fortify Software. Now it's actually managed by OWASP. It's essentially a maturity model with 3 different levels across sort of a framework of different domains and practices. Let's say, if you're doing this, then you're level 1. If you're doing this, you're level 2. And if you're doing this, you're level 3. And it's quite a good model. It's quite prescriptive. It's open source. So, opensam.org, go ahead and look at it, use it. A similar model is called BSIMM, which technically stands for Building Security and Maturity Model. It's got the word maturity in there, but I would argue it's not really a maturity model. It does have 3 levels, but those levels are derived from statistics. In other words, how common is an activity. If lots of organizations do an activity, then it's a level 1 activity. If roughly 50% of organizations do it, it's a level 2 activity. And if it's not very common, it's a level 3 activity. The difference between BSIMM and OpenSAM is primarily that BSIMM is based on a whole bunch of real-world data. So they went around, Digital went around and asked a bunch of firms, hey, what do you do to build security into your software development lifecycle? And they got a bunch of answers, and they came up with over 100 activities. I want to sort of claim my bias here. So I was one of the assessors for BSIMM up until I moved to Norway. So I spent a lot of time collecting, analyzing data from different organizations. So beta 10, which is the latest version, pretty much all the European firms and organizations that are in the BSIMM 10 pool, I was in some way involved in measuring them. So it's a really great resource. It's got lots of real world data in it, and it's a bunch of suggestions for things that you can do. So have a look at it. OpenSAM is trying to do something similar now. So, they're trying to get real world data into their model as well. So I think it'll be really interesting to see kind of how they both then mature or change over time. Okay, enough history. What do we need to build a software security initiative? What do we need to build security into software? And there's kind of 2 different ways we can do this. So I'm going to talk about option 1 first, which is, shall we say, the SDLC-focused approach, which is let's get some activities into the SDLC. And so I've tried to make a completely abstract, agnostic SDLC here, in the sense that it's not waterfall, it's not Scrum, it's not some sort of continuous integration method. These are the sort of roughly five stages that you might go through as part of a sprint or as part of a life cycle run through. And so there's different things that we can do at the different places. So we've got requirements, we've got architecture, we've got code, we've got tests, and we've got production or feedback from ops. So in slightly random but prioritized order, what can we do? Well, if we're not doing anything, let's start with code review. So find a tool that works for you, plug it in, run your code through it, and see what it finds. If it finds a whole bunch of problems, then we know we've got some way to go. If it finds only a couple of things, then we might be in a good position. But that will help us kind of gauge, okay, I mean, how many bugs do we have? Now, tools, automated tools to do code review are really good at finding bugs. They're not so good at finding what we call design flaws. And that's where threat modeling comes in. So while we're designing a feature or a complete solution, we might want to do some threat modeling to basically look at the design, take off our developer hat and put on a hacker hat, and say, okay, what can I do to break this? How can I get to the crown jewels in the app, for example? And we can use that to come up with a bunch of different threats and potential issues that we want to make sure that we design against and implement against. Pen testing, very useful to find issues that have made it through both threat modeling and code review and so on. Usually it's things like application logic bugs. If your code review tool is finding all the implementation bugs, code level bugs, then your pen testing is going to find sort of more application logic flaws instead. And well, up until now, we've just been finding more issues to fix, and that's going to make us kind of depressed after a while. So let's build some security requirements to say, okay, let's avoid all these things that we keep finding, and let's make a standard set of security requirements. If we're using kind of use cases as a paradigm, we could use abuse cases as a different paradigm to say, okay, as a hacker, I want to do something bad, and use that to describe the security requirements. Throughout, look at prioritizing. So using risk analysis to say, okay, if someone can transfer $1 million out of someone else's bank account, that's really bad. If someone can change the background color in the mobile app, that's probably not intended, but it's not as bad. So let's focus on the stopping people from transferring millions of dollars first problem. Peer reviews can be really useful. As part of pull requests, you might even be able to automate some of this to spot issues. Security monitoring as part of your production environment to spot when people are trying to attack you, or to spot when your app is doing something a bit weird. Some people think bug bounties are fantastic. Other people are a little bit reticent about them. They don't think that they're necessarily the best idea in the world. My take on it is, if you're going to do a bug bounty program, make sure you've got some of these other things in place first, because you don't want to practice how to respond to an issue. If you just let external researchers start poking your app and find a bunch of issues, you are then on a timeline to triage it, fix it, and respond to the researcher. If you've got a good process in place by doing it internally first, you're probably going to be a little bit more comfortable. And also metrics. So throughout this whole process, you want to look at, okay, are we doing better than we did last week? So build some KPIs or OKRs or something to measure your progress over time. Now, don't try to do all of this stuff at the same time. Maybe start with a couple of things. So maybe start with just a code review tool, just to get an idea of how bad is our code, and then build on that over time. Automation is very helpful these days. It's come a long way, and I think we can thank continuous integration and DevOps and all those things for that. Security is actually able to use this as a benefit. So it's one of the things where security might be scared of it, but actually this is one of those areas where automation helps us a lot. So this is a Jenkins pipeline that I've built that I don't want anyone to actually implement. It's purely for demo purposes. If you try to implement all these stages and all these tools as part of your continuous integration pipeline or continuous deployment pipeline, it would take hours. But it's for illustrative purposes, just so I can show you all the different tools. So starting off at the left, we check out the code, we build the code, and then we go into kind of a phase where we unit test, and we do what's known as SAST and SCA. Now, what are these wonderful abbreviations that I've just thrown in there? Well, SAST is static application security testing. So that's the code review tools I was talking about earlier. It's not going to find design flaws, but it's going to find coding bugs that are security related. So, if you can find the one that fits in and has the right sort of framework support and everything, then you can fit it in here. SCA is the software composition analysis, which is a tool that looks for, are you using any kind of third-party components that are out of date or have security issues? So tools like OWASP dependency check, for example, is a free one that you can use. It will go through your dependencies and see, oh, you're using an old version of Spring Boot, for example. You should update. And then we go through sort of a check to say, okay, are we happy with the results of the tools? So have we passed like a baseline? Then we deploy into something we're going to call UAT. We do some end-to-end testing, but we also run a DAS tool and an IaaS tool. Now, what are these things? Well, a DAS tool is a dynamic application security testing tool. It basically blindly fires a bunch of tests at your RESTful API, your website, your web app, whatever it is, and it doesn't understand application logic, but it knows what to look out for when it tries to send something that it might be a SQL injection attack. It's going to look to see if it gets maybe an error message back or something that looks like a SQL error message or similar. IaaS is interactive application security testing tool. It's a bit more clever than DAST. So what it does is it deploys agents or sensors on the back end in the application runtime, and it looks for, okay, while we're firing tests at the API or the web app or whatever, how is the runtime reacting? And are there opportunities in the runtime to spot, oh, I see that there's an input value here that's made it all the way to a database call without going through any data validation, for example. So in theory, it's faster and it's more reliable than DAST. It should be fewer false positives. It's a relatively new technology. There's a couple of good players out there already. It's kind of constantly evolving, so it's definitely something to look at. Okay, so that was option one, just focus on the SDLC. Option two is go a little wider, look at the organization and see what we can do across the organization to create what I would call an initiative. So ideally, we want to have some sort of framework to base this on. So we're going to use the software security framework, which comes from BSIMM. And well, what is it? Well, basically, while the guys at Digital were beginning to build the BSIMM, they were asking, okay, what kind of things do all these organizations do? And they went out and interviewed a bunch of organizations. And they were getting all these activities back, and they needed some way of sort of categorizing them. So they came up with these 4 domains. So one is governance, one is intelligence, one is secure software development lifecycle touchpoints, which we talked about a little already, and then deployment. And then within each of these, we've got these practice areas, and I'll go through each of them individually anyway in a minute. So I'm not going to do that now. But it was, okay, all these activities, we can classify them into these practice areas. OpenSAM is a similar one, so you could use that one instead. The idea is here, have a way of looking sort of not just end-to-end in development lifecycle, but also like organizationally, what do we need to have in place? So before I go through each of them, I did want to talk about sort of stakeholders and organizations. So organizations are different. So everyone's got a different size, a different shape, a different business model. And so some things are going to be different depending on where you are. So, but generally, these are 3 stakeholders or 3 groups of stakeholders I think are kind of handy. So executives, these are the people who are ultimately responsible for the company. And they're ultimately responsible for security. A lot of executives don't necessarily appreciate or understand their level of responsibility for security and how in trouble they might be if something were to go wrong, especially if you look at things like GDPR. The level of fines are pretty big now. Then you've got something called the software security group. Oh, apologies, I'm slightly behind on my slides. So you've got the executives, and then you've got the software security group. Now, this can be a team, several teams, one person. It sort of depends on the organization and where you are on a journey, so to speak. Typically, these are the people who are responsible for building, maintaining policies, processes, activities, tooling, and so on. All these things that come together to support security being part of development. Now, sometimes this is a governance role, so they're so in some organizations, they're the guys writing policy and standards and throwing them all over the fence to development and saying, do these. In other organizations, they're more kind of like a hands-on support role. So they're saying, okay, we need to be more secure. So let us help you. Let's sit down and work on this together. In some organizations, the group might span both these responsibilities. So they might have a governance role, but then they're also the ones helping you sort of comply with any kind of things that you need to have in place. Security champions, these are individuals that are in the development organization that the software security group can come rely on to be allies, to help the cause. So essentially they're developers, architects, testers, product managers, whoever in the development organization that think that security is really important and might have a bit of specialist knowledge around it, and are willing to kind of spend some of their time away from their day job, which is developing. And they might spend some time just helping other people learn about security, solving hard problems in design, figuring out why a security bug made it through to production when it should have been stopped, and all these kinds of things. So they're kind of like our help in scaling the initiative, because otherwise our software security group is going to have to be ginormous. Got a question here, which I will cover in a minute, I think. Yeah, I'll take some questions at the end. I'll make sure to answer that one for you, Anthony. Okay, so around these practices. So each of the practices in the software security framework, there's a bunch of stuff we can do. So I'm going to try and sort of just give two or three things that we can do within each area to start off with, and then go be crazy with the other things if you want to. So first of all, in strategy and metrics, have a process. It doesn't need to be a big process. It could literally be, we're going to do a threat model every couple of months, and we're going to plug in SonarQube with some security checkers in our CI pipeline. That is our process to start off with. And we publish it. We try and get buy-in from the execs and the stakeholders to say, we want to focus on security. And so here's what we're going to do. Here's our process. Is this going to work for everyone? Is it going to cause friction? If it's going to cause friction, are there other things we can do instead to achieve the same result? Find ourselves some allies, find some security champions to scale, and then find a way to sort of capture our progress and measure our progress so that over time we can present to the stakeholders and the rest of the organization, look, here's where we're at. Oh, and I forgot to mention that stat. Oh, pardon me. Oh. That stat. Right. I took into consideration some of the activities that are in BSIMM 10, the latest version of BSIMM, just to highlight them. That's the most common activity within this practice area in BSIMM 10, and that is identifying gate locations, gathering necessary artifacts, and roughly speaking, if you do these four things, then you should cover to a certain extent. Compliance policy. Okay, first of all, figure out what you need to comply with. So there may be legal regulations you need to comply with. There may be industry standards you have to comply with. There may be contract things you need to comply with from your customers. Then build some policies to kind of express those compliance requirements and say that you will comply with them. Track your compliance. So figure out how can we use all the data that we're getting out, all these tools and all these activities, can we capture them somehow so we can essentially create an audit trail for if anyone wants to come and look at it. I did want to give a shout out to a company based here in Oslo called ComplianceDB. They are building a tool that should help a lot with this, in the sense that the idea is the tool can gather all the output from all these tools, from static analysis and from all this other stuff that's happening, and give you a way of representing your compliance status. So I think that's really exciting and should be really helpful. Okay, training. In theory, everyone should be involved in making sure that the software is secure. And by everyone, I mean everyone who's involved in producing the software. So that's developers, architects, testers, UX people, product managers, or product owners, rather, and so on. They don't all need to know the nuts and bolts, but they should all be aware that security is a thing that we should care about. And then for the specific roles, you might want to create something more detailed. So, for the developers in the house, sure, yeah, security is important. What does that mean? How do we how do we build security in? Are there tools we should be using? Are there methods we should be using while coding and so on? So we can create roles-based training to address those kinds of questions and concerns. Now, training can be classroom, it could be online, it could be capture the flag stuff, competitions. Let's make it a bit fun. Let's not stick people in a room for 5 days and bore them. OWASP has several apps that are built to basically be vulnerable, so you can play with them and hack them and so on. Juice Shop, I really like Juice Shop, mostly because it's quite fun. It's based in Node. You can set up a capture the flag competition with it, so you can have teams competing against one another in finding the most flaws and so on. So it can be fun. Attack modeling. This is all about figuring out what we want to protect. So data, customer data, sensitive stuff, IP, whatever it is. Figure out who might try and attack it, what their profiles are. So is it a script kiddie sitting at home just trying to deface a website, or is it, heaven forbid, like a nation state trying to get our intellectual property? Figure out what those profiles are. What are their capabilities? Script kiddie finds some tools online, runs them, and doesn't necessarily understand what happens. More advanced attackers are going to have a more kind of long-winded, technically very competent attack. So you want to sort of figure out who these are and what you need to do to protect against them. And you can build like a library essentially of attack patterns and attack scenarios. And what's the idea of this? Well, just doing this by itself is not particularly useful. The idea is use this stuff to educate. So in training, for example, you can use some of these attack scenarios. And then later on, for example, if we're doing threat modeling or something similar like that, we can use this as sort of a base to start off with. If we're sitting there going, okay, what bad things could someone do to our app? Well, let's pull up our list of sort of attack patterns and see if any of them are relevant for us today. Security features and design. This is all about making life easier for developers and architects. So we want to create reusable security components. So authentication, you shouldn't have to re-implement authentication every single time you make a new microservice or new app that ties into your existing infrastructure or your existing solution. Someone writes the authentication service, it's tested thoroughly. Just tell everyone to use that and don't sort of have to run between different things. So yeah, don't force people to reinvent the wheel. The frameworks that we're using, libraries that we're using, a lot of them have really good security properties. So .NET has a bunch of pre-built security functionality in it. If you're building a web app in .NET, chances are data validation and those kinds of things are kind of taken care of for you to a certain extent. And so instead of rewriting or writing stuff from scratch, let's use a library that we know does it for us. And then if you've got security people who kind of understand development and kind of understand architecture and design, have them help out when you're doing design. Don't have them come in afterwards and point out all the mistakes that they could have helped you avoid in the first place. Standards and requirements. Okay, so we can probably create a standard set of security requirements for everything, maybe secure coding standards or something like that. Don't have them in a document if they're not going to get read and used. Maybe publish them as tests as part of your CI pipeline, for example. So, or maybe they're part of an automated check during a pull request. Let's say we're just going to lint for these 5 things. So to Anthony's question, Roslyn has security rules that you can turn on. You can use that and maybe just enable a few of them to test to say, okay, we definitely want these things to be to not exist in our code base. These simple security mistakes we don't want to have, for example. And then again, apologies. Use SDA for checking out third-party libraries and those kinds of things to make sure that we're not introducing any issues. And then on to architecture. Well, let's say, first of all, let's review the design for security issues. So this can start off really simple. Let's just start off by looking for missing security controls. So have we designed in authentication? Have we got authorization in the design? Do we do all the things that we should be doing from a security point of view? and then move on to maybe doing a threat model of it. So instead of just looking for, do we have all the controls in place? Let's take off the developer hat, put on the attacker hat, and go, how can I break the things that we have actually designed in? And then risk rank things. So you can risk rank your apps, you can risk rank the issues that you're finding as part of your design review and so on, to say, okay, we care a lot about the $1 million theft thing in our banking app. We don't care as much about the background changing in our on our marketing website, for example. So we focus our efforts where we should be. Code review, I talked a bit about this already, but use tools that work for you and your technologies and your way of working. So not all tools are going to work well with your specific technology, your specific framework choices. Not all tools are going to work well in your development processes. So if you're using, if you're trying to be as fast as possible in your deployment pipeline, you want to get it down below 15 minutes. Don't use a big box static analysis tool in that pipeline. You can run a parallel, but maybe just have a linter or something like that that's checking for just the basic stuff as part of that process. You want to automate it as part of either your CI pipeline, your pull requests. A lot of these actually have IDE plugins. Checkmarks has a plugin for your IDEs. Veracode does. Clarity does. All of them have plugins for your IDE that help you sort of identify issues as you're coding. So you're not waiting until you commit the code and you break the build. You're finding the issues in your IDE. And again, for .NET, Vuln can help here. And then if you've got security sensitive functionality, so like the authentication bit, the crypto mod API or whatever it is that's security sensitive, do a manual review of those. So it's going to be tedious. It's going to take a little longer, but these are also bits of code that shouldn't change very often. So doing a manual review of them shouldn't be a problem. Security testing. Security testing is not penetration testing. We're going to talk about penetration testing in a minute. Security testing is all about, in your functional testing, look out for security things. So if you're doing, let's say on a unit testing level, do edge and boundary tests. So if you've got an input that's meant to be a positive integer, test with a negative integer, test with an integer that's way higher than it should be, test with a non-integer like a letter or a word or some non-printable character. Do all these extra tests to see how the application responds. And that's kind of the basic. Just make sure that your application responds when it gets input that doesn't fit what it's meant to get. Your security requirements that at this point you might have, build tests for those. So this is particularly useful if you're doing like TDD, for example. You can actually write the security tests up front, you can implement your requirements as tests. And then if you've got really good test coverage, also look at things like DAST and IAST. Now, DAST and IAST doesn't care about your app logic. They care about if I send this kind of input, can I cause the application to do something that it's not meant to do? So it's going to think as an attacker, it's going to be slightly less intelligent about it than your functional tests. But it might spot things that you didn't spot because you're thinking probably along the happy paths. You're probably thinking, this is how the app is meant to work. While DAST and IAST are kind of like big old hammers that are going to come in and just Leroy Jenkins things for you. They're going to try things that you didn't think of. And then pen testing. So get someone from outside the dev team to ethically hack the application. It doesn't have to be an external consultancy. It doesn't have to be like a pen tester from a different company like I used to do. It can literally be someone from a different team within the organization that can be an independent or can give an independent perspective on the app. Whatever you do, whichever way you do pen testing, make sure the results get back to your defect management system. If you're getting a PDF report from your pen testers and it's sitting in someone's inbox, nobody's going to fix the issues. Nobody's going to learn from it. So make sure that they make it back into your backlog or whatever kind of tracking system you're using. And then to really get value out of pen testing, give the pen testers access to everything about the app. So architecture diagrams, specs, documentation, source code, maybe even sit them down with the developers so that while they're trying different things, they're trying to break a piece of functionality in the app. Having access to the developers means that they can figure out, okay, I'm going down a wrong path here, but if I did this, maybe we can get somewhere. And it speeds up the discovery of a lot of issues. Software environment. Okay, first of all, get your infrastructure security in place. There's no point in deploying an app or RESTful API or whatever it is you're building on top of an unpatched operating system in a network that's Swiss cheese. So get those things in place, first of all. If you're using containerization, which I'm pretty sure everybody is doing at this point, it seems, then leverage the security features of containerization. So isolation, robustness, those kinds of things can be really helpful. Web app firewalls, they're not silver bullets, but they are still useful. So you might be using one of these already. They are great at sort of detecting attempted attacks. They can also work really well as a kind of like a plaster or a band-aid on a vulnerability in your code that you haven't been able to fix yet. So they are useful, but they're not going to solve software security for you by themselves. And then last thing, configuration management and vulnerability management. This is when we're out in production, we're running. Expect failure, plan for failure. You probably already have processes in place to deal with things like, a bug or the infrastructure goes down or something fails. Have plans for when someone attacks you from a security point of view, or from when someone finds a vulnerability and actually exploits it. So you've got a way to rapidly respond. Defects found during operations and production, make sure that they make it back to dev, not just so that they fix them, but also make sure that it's a learning opportunity. So, have a bug parade or something. And then, use incidents and use what you learn from monitoring what people are actually doing to your app as sort of sources to build knowledge. So that was a whole bunch of different activities you're going to be doing, and those are the starting point. They're not even like the advanced things that we can do. So that's just a starting point. But what I would say is start small. Start even smaller than I've just sort of gone through now. So pick a handful of activities to start with. Do it across finding issues, fixing issues, and preventing issues. So pick a couple of activities that highlight issues and are designed to find issues, like static analysis or running an IaaS tool. Those are going to highlight issues for you, and then find some activities to help fix those issues to make sure that you can respond. And then also think about, okay, how can we prevent these things from happening in the first place? Define what looks like success by building some OKRs, KPIs, whatever it is you want to use, and then use risk as a prioritization mechanism. So one of the things that security people like myself we got wrong basically when in the mid 2000s and even earlier, was we didn't work with development on building security in very well. And we've learned a lot. So I thought I'd share some of the lessons learned. So first of all, security needs to be part of the development culture. That means as a security person or a security team, we can't be hiding away in a separate room in a secure location, pretending to be our own little intelligence agency. Now, this is something I've seen in quite a few organizations where development don't know what the security team are doing because they're not allowed to speak to the security team, or the security team are kind of hiding from development. What we want is a culture where everyone has access to someone that they can ask about security. So having the security champions program or something similar can really help bridge that gap and make it open so that security are approachable by development. Kind of going back to my original point about sort of processes and conflict and so on, we want to have development processes that include security. We don't want to have security processes that are imposed on development. So security has a bad rep for not being aligned with how development works, process-wise. So we often get these parallel security processes, and we get enforcement of gates by a security team that doesn't necessarily understand how development works, and we end up with a bunch of friction. We don't want that. For example, telling development to pause for 2 weeks because we want to do a pen test, that's not a way to make friends. On the subject of gates, there's a lot of gates we can actually automate. So if security can come up with kind of definition of good enough, as long as there aren't any high risk issues in the static analysis tool, and when we run SCA and IAST, we don't find any new issues, we're good to go live. Like that could be the requirement. Those are all things that we can test and document as part of an automated pipeline. We don't need manual intervention. Some things still have to be manual. So threat modeling, those kinds of things, they're still manual processes or manual activities. That's fine, we can do them. But if we can automate as much as possible, then we can focus our time and effort on the more interesting activities that actually makes use of the human brain more than just standing and staring at code. And that way we can actually deliver more value faster, and we can keep the risk level low by doing this. So kind of in conclusion, look for continual improvement. So start small, then iterate. Scale by finding some allies, building a culture, and building competence in the organization. If we can, automate something. When we automate, we're going to lose some detail. We're not going to find as many issues, for example, because we want things to go fast. So be aware of that. That there's a trade-off between automation and rigor, so to speak. And then think in terms of risk. So using risk to prioritize the really high risk issues, we want to fix them now. The low risk issues, they can go onto the backlog and we can deal with a little later on. I wanted to give you some further reading. So the book by Gary McGraw is quite good because it's still kind of applicable, I thought. But a book that deals specifically with application security and software security in kind of agile environments is this book by Laura Bell et al. The authors here all have experience from different environments where they've been helping agile development teams build security into software. And so they've got some great examples in there and some great sort of case studies and stories. So I think you'd find that quite useful. And again, the online resources, OWASP, OpenSAM, and BSIMM, go ahead and have a look at them. They're all essentially open in the sense that OWASP and OpenSAM are open source. BSIMM is published on the Creative Commons. You won't get access to the data pool unless you have a commercial conversation with Synopsys and join the BSIMM BSIMM community. But the actual report that they publish every year is open and you can use it. And a lot of people use that as a way to kind of come up with ideas for, okay, we're doing these 5 things now. What are other things that we could be doing and where should we go next? And that's it for me. Thank you very much for joining, and I hope you found this interesting.